provide you the answers to exercise 7. Below are simplified diagrams of two electrochemical cells, A and B, which are used in the industry. Cell A is used in purification of copper ore containing silver, platinum impurities. Cell B is used to electroplate a bracelet with a layer of copper. So again, we have that little bit of what's happening there. I think this side is copper, and then that is impure, I guess, because this is pure. So the one that's impure should lose electron. We have already gone through this, and that makes this negative. This makes this positive. That a negative electrode. This a positive electrode. If this is gaining, that means reduction is occurring here, oxidation is occurring here. That is your anode, and that is your cathode. So this should be quick by now, given we've done this quite a number of times. And then we have that pure copper here. Now we use to coat electroplate a bracelet. So we want a bit of this to be lost. So we want to lose mass here so that whatever it is that we are losing, those ions that we're using, Cu2 plus, can go and coat this side. So if we lose mass, we're losing, right, that we're losing electrons. If we're losing electrons, that means they are flowing that way. That makes out through the negatives, that makes this a negative, this a positive. That means this is negative, and that is positive. Again, the process is occurring, the loss of electrons, that's oxidation, and then reduction on the other side. So again, we've now kind of typically broken down the question before answering. Write down the name of the type of chemical cell that's galvanic or electrolytic. Obviously, we're talking electrolytic. As soon as you see a power source, that's a giveaway. All right. Pure copper is used as one of the electrodes in each of the cells above. All right. In which cell A or B is pure copper the cathode? All right, fine. Let's check the pure copper. Already we've done this. We've broken down this bit, and we said pure copper there is the cathode in cell A. So if I can call this cell A, so our answer there, cell A. And then where is it the anode? Let's try to understand what's happening here. At the anode, oxidation is occurring here, and ox, and our red cat. At the anode, there is oxidation. So we already say this is oxidation. That means this is the anode, and that is your pure copper. So again, cell B becomes the automatic answer to that particular question there. Let's check out the next few questions there. Consider cell B initially copper sulfate. Again, the AQ there, it's in water. Right, has a blue color. How will the intensity of the blue color change whilst the cell is functioning? Write down increases, decreases, or remains the same. Now, you might be tempted here to say decreases because we're using up stuff and all that and all that. Remember, we're not necessarily breaking down copper sulfate like we did in the previous one, in the previous question. What's happening here is we're electroplating something or purifying some metal. So this concentration of copper sulfate should remain constant, should remain the same. Why? Because if I'm losing, or rather, if I'm losing one electron, that means I'm producing one, for example, one copper ion there. The copper ion that I'm releasing this side, that very same moment that let's say I'm releasing one of this per second, and then one of that is also reduced this side per second. I don't know if that makes sense. So we actually summarize this more scientifically by saying the rate of oxidation and the rate of reduction are the same. So our answer here should be remain the same, because in a normal electrolytic cell where we're not we're not decomposing the electrolyte itself, the rate of oxidation equals the rate of reduction. Okay, so write down, I'm trying to rush here to cover our time. We don't want to make this too long. Write down the reaction that takes place at the copper electrode. All right, fine. We are focusing on cell B, remember? So let's go and have a look again on our cell B, which is this one. I'm going to try and copy that over here. There we go. We've got that copper. And then we've got the bracelet that we're trying to coat. And we already said negative, positive. So positive there, this is negative. Now, we want a reaction that's going to happen this side, and we already wrote that, so we're not going to waste much time. We said there's oxidation occurring there. Since this is our anode, we say there's oxidation. So we need a reaction that shows oxidation of copper. So we want to check our table here and find copper. Again, like I said, if we don't mention a lot of things, assume copper 2 plus. Also, another giveaway is copper sulfate. Copper sulfate, the numbers that you're seeing there, right? From your, I think grade 10, when you're taught how to bond these things, those are balanced. The sulfate, they kind of gives away the charge that you're going to be working with. So this tells you are talking about copper 2 plus because you've got the same thing here. And if these are the same, when we swap, we're going to ignore those because they're equal and just write copper sulfate. Anyways, a more easier way of remembering this is if they don't really emphasize that we're talking copper 1, do not bother yourself because copper 1 is actually not very stable in our solution of water. So copper 2 plus, let's find copper. Hopefully this time around I'm gonna identify the copper quicker than I do for the other stuff. There we go. This one is not the one because it's not fully reduced. We want the one that's fully reduced because we want to have the copper layer here, pure copper. Right, fine. So there again, this is copper 1, so it's not really what we want. This one is the one that we want. I'm going to highlight it there, the one that's fully reduced there. So, but we want to write it in a manner that shows what? Oxidation, where oxidation says our oxidation numbers should increase, or we should write it in such a way that we show the loss of what? Of electrons. So where should I write that? Here. So I'm oxidizing copper. So copper changes to copper 2 plus 2 electrons. Okay, so you can think of oxidation in two ways. The oxidation numbers change from 0 to 2, so that's an increase. Or you can think of it in terms of loss of electron. So in the products, we've released electrons and we've changed that into that. All right, let's focus on the, if you fancy writing the states as well, it would be nice. Solid, aqueous. All right, fine. Consider cell A. Give a reason why the sludge formed in this cell is of economic importance. Remember, cell A is about refining. Let's go back there. Right, it's about refining some impure substance made up of what? Of silver and platinum. Right, so they're saying, can you tell us the sludge is what the impurities that are going to form down here? Why are they of economic importance? All right, so the impurities that will be left there, particularly, they mentioned silver, they mentioned platinum, and these are very expensive metals, or we can say precious metals. So this is of economic importance because these are expensive metals. You know, they've got so much value. Anyways, let's move on to the next section. Give one negative impact that the energy usage in this process has on the environment, right? The electro refining or electroplating in general, we are using electrical energy. So let me try to write that again. Using electrical energy. And in most cases, that involves, for us to actually get this energy, that leads us way back to the burning of coal. All right, coal. That's one way to think about it, which is not really good for our environment in terms of pollution. Also, we are using a lot of this, so we are consuming a lot of this electrical energy, like I said, and then that means we're burning a lot of coal, and that contributes to air pollution. That's one thing I mentioned, and then which leads to global warming. So this is like an integration of everything that um, we learn generally in geography there. Those who do geography can understand that much better. Anyways, that leads to global warming. We're destroying some habitats to obviously have this ore. Remember, the question is all about refining a, what is it that we have here? Purification of copper ore. So there obviously is some kind of mining involved to get that particular ore that we have. Um, and more and more. So during the mining process, we destroy habitats as well. But I think one of the easiest answers that you can give there are these ones up here. The usage of electricity, um, the impact they have on the environment is the pollution, the global warming, destruction of habitats. This is while mining and stuff like acid rain as well. All right. Anyways, let's call that. I think we have reached the end of our session. Thank you for joining and see you on the next one.